Hello, chat. How are we doing today? I'm not used to streaming. Yeah, I'm not used to streaming at this hour. It's like 11 p.m. Hopefully tonight will go all right. So let me just check my volume. Hello, Doge. How are you doing? How are you doing today? So, PowerShell, right? So we kind of been through this a few times on REWorkshop on and off, but I kind of want to dedicate an episode just to talk about PowerShell. I think we might have mentioned it a few times in the previous Steeler related streams. Let me check. No, apparently this is our first time for a dedicated episode on this. Okay, well, excellent, because I have a lot to talk about. I've been using PowerShell for a long time. I want to say sometime starting from university, so like late 2010s-ish. It's been my daily show of the choice on Windows. Occasionally on Linux if I don't know how to do a certain thing, but yeah. Put a random shop that I own as my street address. Funniest part is it's rented. What was the thing that you need an address for again? I forgot. A trial or something, right? Right, sorry. Let me just so I did come a little bit prepared. When I say a little bit, I do mean a little bit. I just downloaded a few samples ahead of time, so I pretty much just scanned through them just to see if they're appropriate. But I haven't really analyzed them in detail. So, yeah, let's get started. So, PowerShell, as you know, sorry, let me start over. PowerShell, as you know, is developed by Microsoft, and starting around late 2010s-ish, when PowerShell, let me start over. I want to do this part as like part of a clip. Okay. As you know, PowerShell was created by Microsoft at some point, and around the Windows XP era, and later down the line on Windows 8, Windows 10, it started getting more and more development. And as we know today, the PowerShell we know has reached PowerShell 5.1 on current versions of Windows. Around late 2010s, when .NET Core was becoming a thing, that's also when PowerShell Core started becoming a thing, where instead of being something that only runs on Windows, and is now cross-platform, so it now runs on Windows, Linux, and Mac OS. And PowerShell Core has now since started from PowerShell 6 all the way up to 7 now. Now, for Windows specifically, the one you're going to see running in Windows will always be 5.1, unless they change that sometime in the future. Right now, PowerShell is almost feature parity with the one on Windows, the PowerShell Core. Sorry, PowerShell Core is now almost feature parity with one on Windows, which is 5.1. But without considering the existence of PowerShell Core, PowerShell itself has seen a lot of development over the last decade, and is now extremely powerful. Is extremely powerful for both not just your normal user, but also IT admins, but also malware developers as well. And PowerShell, the reason why PowerShell is so powerful is because it is built running on top of .NET, which means you get C# scripting ability, you get access to all of the .NET assemblies, and on top of that, PowerShell supports a lot of ridiculous looking syntax that we'll go over today. So let's get started. So first of all, if you want to know, let's first go through the several basics of PowerShell syntax. So first of all, you need to know variables are defined using a $, followed by the variable name, followed by the value. So if we write this out now, you'll see it is what I exactly typed in, a string that starts with a space ZXCB. Now, once we have made a variable, you'll also notice something a little different if I start typing in various different letter casing. That still works. You can mix variable casing, you can mix casing in for the majority of PowerShell. How did you do that? How did I do what? Let's see, what else? So PowerShell itself is not case sensitive. That also means you can do things like, let me start over. PowerShell also has a bunch of commandlets available. Instead of something called a command, let me start over. PowerShell also has a lot of different commands available. On PowerShell, they're called commandlets. And to use a commandlet, the format would be in verb-noun or verb-adjective noun, something like that. So, for example, if I want to get the current date, I type get date. And as we mentioned earlier, it can't be any casing you want, but the formal way to write it would be in title case. But once again, you can write in any casing you want, so you can type really funky things like this. It'll still work. The background is from Windows Terminal. You can Windows Terminal supports any kind of command console-based output applications. So you can have PowerShell, you can have command.exe, you can have Python, etc., etc. They aren't case sensitive. Yes, they aren't. So you can type as funkily as you would like. Now, aside from that, you can also get help. If you aren't too familiar with how the commandlet works, you can type dash followed by question mark, which will give you a help, which will tell you how the commandlet works. And the proper way you're supposed to do this is get help followed by the commandlet. But dash question mark is just the easy way to do it. Now, by default, all the commandlets are they're position sensitive. So, let me start over. By default, PowerShell also lets you take in arguments via the argument name. For example, if I want to type get date, I can also follow it by a date time or millisecond or year, etc., etc. For example, if I want to set a date, let's say 2024, then I'll replace the current date, but with the years to change to 2024. Now, you can also shorten it to the shortest possible string. For example, instead of typing out -year, you can also type whatever's the shortest in the list of variables. So let's say if there isn't anything that starts with a -y, that means you can also just type -y. It'll assume it as year. So that means you can have many different types of, you can have many variable names that will still count as valid by PowerShell. So You can type get date -y 2024, and maybe if there isn't one that starts with -m, as you can see there is actually. So there is -month and -millisecond. So if I type just -m, it'll tell you, hey, it is ambiguous. You need to have more. You need to have something that's not month. You need to choose one of these. It needs to be month, minute, or milliseconds. So let's say if I want minute, I can't just type -mi because once again, it's going to be ambiguous. For example, you're going to get minute and milliseconds. The shortest one for minute would be min because there isn't any other arguments that starts with -min. Now, with that in mind, you can also start to write really, really funky ones. So, for example, if I want to type get date, you can mix the variable casing. So that it becomes something that is really hard to read. Like that. So that is generally how you do PowerShell obfuscation. You start to write, you start to mix different layer casing, and then you can also have different arguments in various forms. Now, in addition to that, PowerShell also supports wildcards. So if you want to do, for example, you can use something called a get command, which will list you all of the commands that are available, all of the command lists that are available in the current session. So for example, if I want to get a command that's, for example, write host, you guys might be more familiar with this, with the colloquial echo, since echo is basically write host. We'll get to why in a little bit, but just so you know, when we're using get command, it also supports wildcard. So for example, I can do, let's say I want to do write host, right? I can see that it has WRITE-HOST. Now, you can use wildcard to specify what kind of command you want, and you can substitute the characters. So for example, I know it starts with W, ends with E before a dash, and then it starts with H again, and then ends with T. There you go. We've got write host. So you can even use this. Oh yeah, to get the every commandlet also possibly has a member. Now you can get the list of members by using get member. So for example, now we have this write host is actually a type of commandlet info. And as you can see, it has all these members. Now to use a member, you can refer to it by surrounding it with parentheses, and then followed by the member name proceeding with a dot. So there we go. We've got the name. And now you can also follow it by, in PowerShell, if you want to use a string, in PowerShell, if you want to substitute something in a string with an actual object, you can do quotes and then followed by $, parentheses, and then followed by whatever variables you have. For example, if I want to do get command, something like that. There you go. And then I can do whatever I want back here. And now we have write host ZXEV. Now, let's say if I want to execute this thing, we have something very handy called invoke expression. This might be better known in other languages as eval or exec. So this is what invoke expression normally does. it will invoke whatever commandlet or script block that you've given it. So we can do write host hello world, which basically means it just executed this. Now, before we move on to, once we, since we have something that earlier since we have something earlier that wrote out write host, write host ZXCV, we can now pass this on to invoke expression. Now, as you can see, there is a pipe character that I just typed in. A pipe character pretty much functions like any other shell-related languages. So you can put whatever input variable, you can put whatever input is in front of it and pass it into the commandlet that's after it. So we can now do write host ZXCV, and then we invoke it. And there you go. It just spat out the XCV. So we have now figured out that we can do mixed casing. We also know that we can use wildcard, and then possibly mixed casing as well. And now we can use invoke expression. So that's already quite powerful already. If you're writing obfuscated PowerShell. Now, the next level would be something called an alias. So in PowerShell, there's this thing called alias, which gives you a list of commands. When you type out get alias, it'll give you a list of commands that corresponds to the actual commandlet themselves. So this is why you can type ls and it'll work, because ls actually corresponds to get child item. So that's why the common Linux related Linux related commands actually work fine here, because they have been aliased for you. So now that we know alias exists, we can also do, remember when we did invoke expression? Invoke expression actually has its own alias called IEX. So back to the command we were doing earlier, we can now do IEX. And as you can see, it'll still work. Now, get command also resolves to GCM, so we can do GCM. And now we can mix all of that. And now it looks like this. You can also do an end expression. For example, if I want to do, let's see, what is the okay, before we move on to that, actually, let me just mention this real quick. So PowerShell also supports typecasting. So let's say if I want to see what integer that the ASCII I corresponds to, I can cast it as an int. And as you can see, it won't work because it is currently treated as a string. So we'll have to cast it as a char first. So we now know that it corresponds to 105. So knowing this, we can do the reverse of it. So we can do this. And now we have IEX. Now I don't quite remember how n works. I have to double check. Okay, so n directly invokes the thing that's after it. So yeah, that worked. So as you can see, now we have invented a new way of, quote unquote new. We have now invented a quote unquote new way of calling invoke expression. We can use alias. We can then turn that alias into a bunch of numbers. Now, this is pretty common for obfuscating in general. The typecasting thing is very common across obfuscated PowerShells. So, after that, we can then take a look at some of the examples that we're going to be going through today. Actually, one more concept before we go on. So, in PowerShell, there's something called a script block. So a script block is basically what it stands for. It's a block of script that PowerShell can then invoke. For example, to create a script block, you would do it in a curly brace. So for example, if I do write host A, that is a script block. And then you're going to call invoke on it, and then it'll invoke that script block. There are many, many ways you can go about invoking a script block. But this is the calling .invoke one would be the easiest thing for it. There are many, many more advanced ways you can go about doing it. For example, in PowerShell, there are a few a few variables that are always going to be there. We can view the variables by using get variables. You can also type gv, which stands for get variable. As you can see, there are quite a few things that have already been defined. Now, we made a few variables earlier. By the way, I'm using PowerShell core, so let me switch to regular PowerShell actually. So if I type gv again, as you can see, there are quite a few options here you can play with. For example, the preferences. But in our specific context, there are a few interesting things you can use here. For example, you can use execution context. Bye bye, Doge. Have a good night. So for example, there's this thing called execution context, which will give you quite a few things for you to play with. You can even get the member from here. And you can actually invoke things from here if you wanted to. I think it was... What was the execution context I was using? Right. Actually, before we go on, so since as we mentioned earlier, PowerShell runs on top of .NET, which means it runs on top of various different assemblies. So pretty much everything you do is going to be associated with an assembly. And now with assembly, you can also get the various type names as well. So we can even do get type on many different things. So for example, I can do this from string. We'll be able to get the string class from here. Now there are a lot of things you can do with a assembly info. Another thing you can do is actually create can actually get member names and then use that as a part of obfuscation as well. For example, if I want to get, like, for example, the letter S, I can type, I don't know, like, I'll grab like the first member, .name, and I could just take like the first one. There you go. So there are many, many different ways you can go about obfuscating things. Now, I was talking about execution context earlier. You can do, like, for example, we saw earlier in the GM that we can do invoke command as well. And in invoke command, we can see that it has actually quite a few things for us. For example, we can use get command let, which functions pretty much the same, similarly to get command, but also not quite. So if we do like get commandlet. You can do like the same thing that we got earlier. Oh wait, yeah, I had to do get commandlets. There you go. So now we have right host again, except without actually calling get command. Sorry, I'm just checking a few things that I typed up before. So, as we mentioned earlier, it runs on top of a bunch of assemblies that are in .NET. So you can also reference types by using the square bracket. So for example, if I want to do like, I don't know, the encoding class. And this will be how you reference the type. Now you can access the member with the : : for example, if I want to access UTF-8 and then call get, let's just say get bytes. And there you go. Now we have a way of calling the UTF member under the encoding class, and then call the method get bytes. Now, there's also this very neat thing in PowerShell called a type accelerator. That's actually something that I only recently learned. So you can do assembly get type and type system management, automation, type accelerator. Okay. Now, type accelerator is a way of basically renaming and redefining the various types that you might want to reference. Now, for example, if I want to create a new type that refers to the encoding class, I can do accelerator add let's just say enc. Now I can type encoding, hang on a second. Did I type something wrong? That should work. Oh no, wait. Sorry. And then we can type : There we go. Because add is a static method, I believe. You can check. So now we have created a new type accelerator. We can now refer to it using the name we created, so that will be enc. There you go. So now we have a new way of calling system.text.encoding with a shorthand enc. Okay, so in the rapid fire of 30 minutes, I've taught you basically the basic and some of the advanced part of PowerShell scripting. So now we can take a look at the samples. Before I do that, I need a restroom break. I'll be right back. Sloan. Hello, Cat. Sorry for the late reply. I was low focus there. Does anyone actually obfuscate their code to such an extent of utilizing all the techniques you mentioned? We'll see. You'll see soon in the samples that we're about to show. Now, there's also one other basic that I forgot to mention. Very, very basic stuff. So, each different command can also be separated by a semicolon. For example, if I want to type right host, hello world, and if I want to follow up another thing, I can do a semicolon, and then I can do the next command that I want. There you go. So, basically, in most of the cases for PowerShell, if you see a semicolon, most of the time, you can safely do a next line. You can safely replace all the semicolon with the next line. A lot of times people will write single line scripts, which may end up being very difficult to read, and that is why the first thing you might want to do sometimes the first thing you want to do would be to replace those semicolon with a next line. Man, it's really hard to, for some reason I find it very hard to talk today. I think I'm tired. It's 11 p.m. This is going to be very difficult for me when I'm about to make this into a clip or something. Okay, so if we take a look at some of these samples here, I don't know what sample is what. I just downloaded a bunch of them from abuse.ch. So some of them might not be very helpful. Some of them probably will be for our illustration. So, okay, so the first one we're seeing is not actually a PowerShell command yet. It technically isn't, because as you can see, it is actually calling PowerShell. Now, for calling PowerShell, there are various ways you can go about actually calling PowerShell.exe. Once again, the same shorthand argument thing still applies here. So for example, if I want to call, let's say, where is it? If I want to call -no profile, I can type PowerShell.exe -nop, which would stand for no profile. Now, if I want to do, like, for example, no window, there's something called a window style, which would be, where is it? Window style, there it is. I can type PowerShell -wind, because that would be like shorthand for window style. I could type hi, which would be hidden. As you can see, we have a PowerShell instance running in the background because the main window has been hidden. Let's exit out of that. Now, there are also other ways of passing in PowerShell commands. You can either type the command in as is, like for example, if I want to call PowerShell with the command right host A. There you go. I've just called PowerShell that only does right host. Now, another way you can go about passing in command is something called an encoded command. There you go. This encode command takes a UTF-16LE encoded base64 string. So, let's open up Server Chef real quick. If I want to do right host A, I can convert this. First of all, we need to encode it first. Encode text into UTF-16LE, and then we turn into a base64 string. So now we can type PowerShell. We can call PowerShell.exe-enc, the base64 string that we just put in. Ooh. There you go. We've just called right host. So that is basically what you're seeing right here, right now, is a encoded base64 is a base64 encoded string for a PowerShell script. Okay, now, knowing what it is, we can pass this in here from base64, and then we decode text from UTF-16LE. There you go. Now we have the actual command itself. So now I can save this as extracted. Now, you were mentioning whether or not anyone actually obfuscated their code like this. Here you go. Here's an example of what we just been through. So, for example, earlier we mentioned that invoke expression can be aliased into IEX. Now you can, as soon as you see this, the first thing it stands out to me would be this line. Because first of all, if you don't know what shell ID is, don't worry. You can put in your PowerShell session, and you'll see that it translates to I. And why is that? Because if we do shell ID right now, you'll see that it actually stands for Microsoft PowerShell by default, anyways. So that will be I. That'll be E without looking at it. Because, like, what else could it be, right? Do 13. There you go. It's E. Pretty much, if you've ever seen a 3-letter word followed by... Sorry. If you see a 3-letter word that is preceded with a pipe sign, then most of the time it's probably going to be IEX without even looking at it. So as you can see, it used end and then called IEX. Now, the fastest way to go about deobfuscating something like this is just simply removing the IEX. Removing the IEX means that it won't be executed. It won't be invoked. So now we can take all of this and just paste it in our shell. Now, of course, you want to do this in a sandbox environment. But as you can see, here you go. So now we can set clipboard. We can now pretty much just do this. Okay, as you can see, we've got IEX again. One thing I forgot to mention, there's also something called a dot invoke. Dot invoke works kind of similarly to the end sign. So pretty much anything you put after it will be executed as a series of commandlets. So if I would do get host, write host, followed by, there you go. So as you can see, in this case is calling IEX again, followed by whatever this is. Now we can once again do this. And now we've got that, which we will replace the content with again. Sorry, give me a moment. Okay, so now we see that it starts with a verbal preference to string. So by default, the verbose preference would be, if I remember correctly, silently ignore, silently continue. Yeah, silently continue. So in this case, is taking 1, 2, 3 of that. Right, we got to string it first. So it takes this part of silently continue, which is, oh, sorry. It takes this and this part. So the comma here would stand for the various index numbers that you have in the string. For example, if I want to do like 1, 3, 10, it'll give me the second letter the 4th letter and 11th letter, because the index starts at 0. So in this case, it is taking the IE from assembly continue, and then it adds 8x after it. There you go. And as you can see, it is not a string, but rather 3 chars. So that is why a join is called after it. A join does pretty much what it says. It joins all the characters together. If you don't give it any values, or if you give it a empty string as a value, then it'll concat all of them into one single string. Now, of course, you can normally, the way you would use this is you would, if you want to like put a bunch of different values together and separate them by using, let's say, comma. That is normally what you would use this for. So in this case, it's calling IEX again. Once again, we can disregard all of that. Just copy this part. So now we're almost there. As you can already kind of see what this is already. It is invoke web request followed by the URL, and then another IEX is called. So now we have the final payload, which is this. So we went from this very long base64 string all the way down to this. Now this is a relatively easy example of an AlphaScape PowerShell script. Let's take a look at another example. Let's take a longer one. Once again, I have not seen these samples yet. Let's turn off, so let's turn on word wrapping. So a lot of times in PowerShell, in these AlphaScape scripts, a lot of times they'll do is they'll try to add in extra things that don't make any sense, or it's pretty much just there to pad things out. For example, you might see unsensical arithmetic or math expressions that don't do anything, but is there to pad out all the lines to make actual static analysis a little bit more annoying to look at. So in this case, we can see that there's a bunch of these variables that don't do anything. How do I know they don't do anything? If you're using VS Code, then it'll tell you, assuming you have the PowerShell extension installed, it'll tell you if a variable is used or not. If it's underscored yellow like this, that means it is not used. You can see that when hovering over it. Assigned but never used. And there's also a lot of these counters that don't do anything. You can also remove these. How do we know if something is actually used? We can also do a quick search. Is there anything meaningful being used? No, they are all doing pretty much nonsensical things. So, knowing that, we can simply remove all of them. So, we can use regex for this. Now we can just replace. Here you go. Now, as you can see, it also has many different new lines that don't do anything, so we'll also replace those new lines. Now, there's also a lot of these catch errors that don't really do anything, because obviously this won't fail. So we can do the same thing. And then replace them with nothing. Now, what about these what about these set scalar ones? They also don't do anything. Do this. Oop. Sorry. There you go. How about these tests? Do these rand index do anything? Nope. Once again, same thing. What about these get randoms? They also don't do anything. So we can do try. Here you go. Get rid of them. We're already slimming down quite a bit. This also doesn't do anything. Replace. Also doesn't do anything. Here we go. How about these test ones? Also nothing. Now, you might think this is tedious. That's fine. Because I'm just more or less demonstrating how you go about doing this. Now, realistically, the fastest way you can do this is try experimenting with LLM. LLM is actually great at this, especially for scripted languages. A lot of times you can actually ask them to remove the noises for you. Claude is especially good at this, but once again, beware. There will be possible hallucinations. Always be aware of what spits out. Okay, all of these while loops also do nothing. Okay, this is already looking a lot more readable than before. Still not quite there, but this method of obfuscation I actually hadn't seen before, but it makes sense. So all of these are basically script blocks of some kind. That is a very creative way of calling it, actually. But as you can see, it also refers to all of these, like, with... Right, host. I wonder how this works, actually. Hang on. I actually don't think I've seen something like this before. What? Hang on. Huh. Does this actually get evaluated or not? I actually don't think it will. Are all of these also just noise? Because like if you actually look at the commandlets it's writing out, they actually don't make any sense. Like for example, get net adapter doesn't have a -r, I believe. Yeah, it doesn't. So these commandlets are actually nonsensical. So they're also being used as obfuscation then. So in that case, we can also do this. Now we're back down to just but that doesn't make any sense. Then if that's the case, then this doesn't really do anything. Huh? Let me check abuse.ch where this sample came from. What's this labeled as? This was EB6. E6B, sorry. SHA-256. This was from Ghost Socks. Huh. It is supposed to drop a file. Does it actually do that anywhere? Let's go back a little bit to the beginning. Oh, wait. I might have accidentally undid some of the commands. Okay, so before we clean that out, let's do a replacement on all these semicolons. Preferably once prefixed with that. Now we can do this. Oops, without the new line. Is there anything new from that? No. I just want to double check. What happens when I execute this? Really? There's a download data from... Where? Line 52. Revert. No? What? Is there an IEX here somewhere? I like this obfuscation. It's actually interesting. Oh, there it is. That IEX shouldn't work. Huh? I want to check. Everything up until here. Does that do anything? What happens when I do this? Nothing happens. Okay, if I remove this... What? Huh? Wow, I like this obfuscation. It is very fun. Holy shit. Okay, we'll get into how this works in a little bit. I need a restroom break. I'll be right back.
the shining golden signs.
All right, I'm back. Hello. Right, so, out of curiosity, shortly after the restroom break, I actually asked if Claude could figure this out. I figured it would actually get tricked by the commandlets here, but no, it actually was smart enough to figure out this is it's not executing commands like I thought, which like I expected, which is yeah, it doesn't do anything. However, what it actually does is that it's actually doing variable assignment. So this doesn't do anything. However, this end does this do anything? Holy shit, does it? No? Hang on. So if we copy this and then we check the GV, holy shit. Okay. So it's storing the variable values inside these. So they're actually not useless. Okay. So let's go through all of that again. We'll remove the clearly doesn't do anything once. I mean, not that we needed to. We pretty much only need to run until the IEX, but I figure we might as well get down to as close as possible from what we were doing earlier. So we'll clear these out as well. These as well. This probably doesn't do anything either. Yep, nothing. We'll do this. There are even unused variables, really. Wow, I guess the whatever engine this is doing is actually doing a decent enough job at evaluating whether or not variables is used. So we can actually remove all of these by hand, because I don't think there's an automatic way to do this for unused variables. We can go down here, clear all of these. I assume they're not used anyways. I'll take its word for it. We'll see if that is the case once we get rid of all of them. You can actually see that's basically a base 64 string. Get rid of all of these as well. Oops. Okay. So now what we can do is, assuming all of these are in order, then we can pretty much just do all the way up until the first that. And then we do /n. And then we replace those. Ah, wait, some of them has replace those with /n. Replace those. Oop. Right. Should probably do this. So now we have a base 64 string. Now, does this translate to anything? Yep, there we go. Kinda. So something definitely messed up there. I think that might have been the base 64 strings earlier. Regardless, though, that was just more or less to test if my theory was correct, which it was. Once again, the fastest way to do this would be pretty much just run everything up until the IEX. So there you go. Anything before the IEX, we just run. Oop. Or we can just save that and then run that, which will spit out the deobfuscated one. And this will be good enough to look at. There's barely any obfuscation there. If they wanted to, they could obviously have another obfuscate layer here. So, once again, the fastest way to checking what a PowerShell script does is, first of all, check if there's IEX. If there is IEX, then get rid of it, and then try to evaluate anything before that. Now, of course, there might be IEX in between as well, so you might want to be careful as well. So now we can take a look at some other ones. Okay, so this one actually barely has any obfuscation, but this is also something that I think would be worth mentioning. Since, as mentioned, we are running on top of .NET, that means we have access to C# scripting as well. So since we have C#, that also means we can call deinvoke. And if we can call deinvoke or pinvoke, depending on whichever you like to call it, depending on the exact use, we can do pinvoke through PowerShell. So in this case, create a new type called memory patcher. So watch what happens after I call this, after I run this part. Okay, so now we've called it. We know that there's a class name called memory patcher. So as previously mentioned, if you want to refer to a type, you would do square bracket and then followed by the name of the class. So memory patcher. There you go. Now, in the script, as you can see, it created a new class called memory patcher. It also created a few static members as well. So in this case, it actually created 3 pinvoke members for us. We can actually use them directly. So if I want to do like get module handle, I can. Like for example, what module is there? NTDL. I can just sorry, I can just do that. So now we also have the power of Win32 API in here. So with the power of Win32 API, that also means we can do shellcode allocation. We can do shellcode execution. We can inject into other memories. We can read from other process memory. We can do whatever Win32 API is capable of, as long as we have the privilege to do so. Now, what is it doing here specifically? So, first of all, the comments are actually written in Chinese. And this feels more like it's written by an AI because there's a lot of comments. Usually, the fastest, so the usual way to discern whether or not something is written by an AI would be the amount of verbals comment. Now, obviously, that isn't 100% correct. Like, of course, there are humans that write a bunch of comments as well. But if you see like comments like on very, very easily understandable things, like anyone look at it would be like, yep, of course that does that. Why does it need a comment? Then it's usually written by an LLM, usually. Now in this case, it is actually doing something called bypass. It was doing something called MC bypassed. Now what is MC? MC stands for anti-malware scan interface, if I remember correctly. Let me double check. Yes, I am correct. Anti-malware scan interface. So, by default, if you have Defender, then which most machines do. Oh, thank you for follow, Puppet Dilda. Welcome. So, if you want to do like, ow. If you want to, so if you have Defender enabled, which you do by default, then pretty much any PowerShell command you enter is going to be monitored by Defender. Normally, if you are on a place where Defender is enabled, if you type something like invoke mimikatz, then you'll be stopped by Defender. In this case, we don't, because our Defender is disabled on this machine. But if you do this on a real machine in your PowerShell, which this string doesn't do anything by default on its own, by the way, but if you do type it in anyways, then your local PowerShell instance will yell at you. It'll say, found potentially unwanted software, etc., etc. So this is one quick way to test if Defender is working correctly on your machine. Now, what it's doing here is internally, when you execute a command, that buffer is sent to the MC interface. The MC interface is then connected to Defender. So when you put in a long string of commands, or like any commands really, all of that will get scanned by Defender. So what it's doing here is it's actually finding the MC DLL, right? Let me check. Yep, there is. It's finding MC.dll, which is the module responsible for loading the anti-malware scanner interface. If it finds it, then what it'll do is it'll look for the method name called mz scan buffer. I'm gonna follow. Triplified. Hello. So if we go into a get current process byte patch, it takes the func name, which is, yep. So it locates the export function called MC scan buffer, and it patches it using by overriding over the memory. As you can see, it changes the memory permission with virtual protect. We go down here. First of all, it's trying to find the function address. Right. So it's trying to find the return followed by N3 N3. And it's going to go backwards and then try to find the first GNE command instruction. And it goes back. After it's found that, then it's going to change the memory protection of it and then override it with JE, which would basically skip the jump. So, oh, sorry, invert the jump. So that's the way it works. It basically pretty much bypass the MC interface. Now, of course, normally if you do this, these days you'll probably get caught by Defender. But in some cases, this might work. Basically, there are a lot of different MC bypass out there. The most common one would be something similar to this, where it's basically a byte patch. There are a few more unique and creative ones that have been covered. There's one on top of my head, but I don't quite remember. But basically, if you look up MC bypass and then try to skip the ones that do byte patch, then yeah, that'd be one way for you to do it. Now, without even looking down below, I already know what this is. This is Cobalt Strike Stager or Beacon, depending on the file size. How big is this? This is probably a beacon. Yeah, it's a beacon. It's pretty big. How do I know this? Because the Cobalt Strike Beacon PowerShell payload always uses the same set of methods for loading the shellcode. So pretty much this func get proc address, func get delegate type. These are pretty common for Cobalt Strike Beacon loaders. And the way it usually works is they'll take a base64 encoded string that has been XOR encoded, and then it'll XOR decode at runtime, and then allocate the memory, and then run it. So in this case, it's this long string, and then XOR decoded by 0x35. Not just 35, not 0x35. Okay, next one. This one's pretty similar. No, that's the same one that we just looked at. This one. Okay, that's more just writing the file. That's not too interesting. Okay, so this one is a little bit more annoying to look at. So There's another method of obfuscating that would be white space obfuscation that you can use in PowerShell. You can pretty much, if you want to know how it works, you can go take a look at invoke obfuscation, which is something that's from a long time ago. But invoke obfuscation is still a good case study for if you want to learn how obfuscation on PowerShell works. But in this case, we don't even need to do that because it's literally just calling invoke expression at the end. So we could just just grab all this. And then run it. Oh, hang on. Yep. Would be easier if we just removed invoke expression and then run it. Oh, was it? Oh, I need to go to here. All right. Don't store it. Thank you. There you go. So now we have this. Oh, this doesn't even use any white space obfuscation. It's literally just there to pad things out. Okay. Well, that makes things easier. So we can just do /n/n. Place with just one line. And then we can do format document. There we go. So now we can see that it's trying to load the assembly from the hard-coded string here, which is clearly a PE because you can see it starts at 45A. This page is basically just unhex and change it into bytes. That's it. So what follows is a .NET payload run by reg service. Right, so these days LLMs and AV engines won't be fooled as easily, but sometimes human will fall for this, which is if you have a lot of comments in a PowerShell script, and if your variable names are a little bit more legitimate looking, then sometimes the analysis, the person that's doing the analysis and or the AV engine might think that it's legitimate. So what a lot of times people do is they'll come up with like very legitimate looking function names and then very legitimate looking operations down there, and then followed or preceded by a large comment block that describes what this function does. But in reality, what it's doing is actually something completely different, and it's actually doing something malicious. Now, in this case, however, it's just padding out things with comments. And earlier, if you did this, some AV would actually think that this is safe just because of the presence of tons of comments. Obviously, that won't work really well here these days. But as you can see, it's pretty much doing what the techniques we've mentioned earlier. It's pretty much just, okay, here's a bunch of things. Here's a bunch of, for example, this is an array. It's just going through all that, and then actually, it's not even doing anything meaningful because it's just assigning to null. Sorry, it's assigning the values to null, which pretty much just discards them. This is probably the only thing that's actually doing, which is decoding the payload, which is then called here. Yeah, it's it looks very long, but in reality, all it's doing is just base64 decoding and then XOR decoding it again, and then loading the .NET assembly. Once again, the rest are mostly just noise. So, also another thing I forgot to mention earlier is since this is .NET, that means you can invoke and load assembly as well. So the most common thing you'll see is assembly load. That is for loading any .NET assembly that might be valid. It takes a byte. Sorry, it takes a byte array. And then you can, once after the assembly has been loaded, you can then call invoke on it. Okay, this isn't even, there's not even much here. It's just running an encrypted script. Now, with that being said, we can also just, if we're not sure what this is, then we can just run it. It's that easy. So once again, the thing with PowerShell analysis is you don't actually want to do the actual hard lifting work. You can just let the PowerShell engine do the evaluation as long as it's not actually running the malware. Now, of course, you should do this in a VM, but the reason why I say that is because sometimes you want to figure out what the script does before it actually loads in the malware. Okay, this is a little too long. Better way would be just removing this. There. Here we go. So now this is once again just loading an assembly. By the way, if you ever see a base64 that starts with TVQQ, then it's probably a PE, because that's what MZ translates to. This is more or less the same thing. That is the same thing. That is what we've seen. Okay. Let's see what else is there. This 11 megabytes one? Yeah, okay. So in this case, is all in single line. There's no line break. So once again, the first thing you will do is just splitting them up. Now this is already a lot easier to read. I can already see that it's, first of all, I don't think these are used. These don't do anything. These don't do anything. What is this used for? It is this. Just grab this. Let PowerShell handle it. If it will respond. Or it's gonna freeze. Sure. Yeah, that buffer might have been too long. That's fine. By the way, when you're analyzing PowerShell, it's best that you use the built-in PowerShell instead of PowerShell Core, just in case of compatibility issues. Here we go. Now we have that. Now we can just be like, okay, so this is this. Very long. And it is a JSON. takes that member. Ah, okay. So what it's doing is reading from the JSON, and then basically all of the module names and module bytes are stored in the variables. So what it's doing is basically just iterating through the members and then writing the bytes out. And here, then it just runs it. Yep, through Explorer. Okay. Hi, so could you write an entire script for, I don't know, legitimately downloading movies, but add 1 or 2 very obfuscated sentences to bypass human analysis? Sorry, I got here very late. So, that is something a lot of people would do. In fact, is what many of the click fix style attacks would do. So, you know how you see one of those CAPTCHA looking pages? So what it does is at the beginning, instead of you pasting in the script and actually seeing the malicious part, what it'll do is it'll pad out the beginning and the end with very legitimate looking strings. And since the user is going to paste the command into the command prompt, into the run window, they're not going to see the middle part. And they'll just see either the beginning or the end. And it's pretty much what those social engineering attacks are like. The actual malicious part is in the middle, and what actually happens there is a lot of times unknown to the person executing it. So yes, you can put very legitimate looking, or sometimes even legitimate things at the beginning and the end, and put malicious things in the middle. It is a very common obfuscation method that's not exclusive to PowerShell. A lot of scripting languages also do that. So for example, a very common tactic for executing malicious JavaScript, when I say JavaScript, I mean the ones run by the V8 engine. For example, Node. What some people will do is they'll put a first line of a comment, and then they'll pad it out with like very, very long white space, and then followed by a malicious script. And if they don't have word wrapping turned on, then they will never see it. It's pretty much the same idea here. So in fact, you can actually do the same in PowerShell as well. Like I can do like comment, here's my comment. Well, actually that won't really work because if this is comment, then it won't. The entire line will be treated as a comment. But the reason why they can get away with it in JavaScript is because there you can have a start and end of a comment, and then immediately followed by executable scripts. But you can't really do that in PowerShell. But as I said, you can have like very, very long comment blocks. And then do like hi, something like that. By the way, one thing I forgot to mention is with PowerShell, unlike other languages, other sane languages, PowerShell uses backtick as escape string. So instead of //n for new line, you would do backtick n. So for example, if I did hello world like this, you would expect it to write hello, line break world. However, what you'll see is that doesn't happen. So to escape a string in PowerShell, you use backtick. So there you go. Now we have hello, actual line break, followed by world. And also, brackets are sometimes treated as special characters as well. That's also why you can't really navigate to paths that have brackets in them without using escape. So for example, if I name a folder called cool folder, Watch what happens when I try to navigate to cool folder. It'll be like, what is this? I don't know where it is. You have to escape it. And then you'll be able to get in. Alternatively, you can use literal path. Then you'll be able to get in as well. This is why sometimes you might see commands, PowerShell scripts that use, for example, gci-lit, and then followed by the folder name. Just say, name it this cool folder. gci-lit. Hey, there you go. Put something in there. There you go. I'm gonna switch to some other music. This is getting a little too intense. Okay. So what other things can I talk about? Let me see. Now, if you want to learn how many of these obfuscation techniques work, then I would suggest checking out Invoke Obfuscation and Invoke Cradlecraft. Invoke Cradle, what was it again? I forgot. Let me check. Give me a bit. Right, I think my network card died. I think it's Invoke Cradlecraft. Yeah, it's Invoke Cradlecrafter, which is like a newer version of Invoke Obfuscation. Couldn't these little shenanigans used to bypass LLM analysis? So, at the very beginning, and in fact, only a few months ago, actually, let me rephrase this. So, a year ago, VirusTotal introduced something called Code Insight, which would be used, which is basically an LLM specifically focused on analyzing various scriptable languages. And that includes Office documents as well. So Office documents with macros. One of the supported languages is PowerShell. And when it was first rolling out, Code Insight was actually very bad at the job. Some of the stuff it would see, it would sometimes make sense. Sometimes it'll come up with nonsensical output. Sometimes it'll be misled. Of course, using something like prompt injection. But even without prompt injection, it was actually very super not effective against obfuscated PowerShell scripts because it couldn't really understand what it was doing. Now, fast forward a few months. I don't know about now. I think the Code Insight is on VirusTotal is still really bad. But if you were to feed something like an obfuscated PowerShell script to something like Claude, it'll actually figure it out pretty well. So, for example, I will pull up a instance of Claude on Perplexity, because that's what I have on the hand. Okay. Okay. So, let me pull up a script real quick from our samples. Expand this. Let me grab one of the stuff what we're looking at. Okay, for example, if we bring up the E6B one we're looking at. So, Claude is actually very good at this. Not just PowerShell in general, but like, sorry, not just PowerShell, but like scripts in general. It's actually very good at deobfuscating them and understanding what is sometimes being used as tricks against human analysts. So for example, if I ask, what is the following PowerShell script doing? Now, to a human analyst, you might think is calling a web request to somewhere. But no, if we actually look at the parameters, it actually doesn't make any sense because invoke web request doesn't have a parameter called log name. So clearly it's not doing something else. Sorry, it's not doing invoke web request, but it's actually doing something else. As you can see, Claude was able to figure this out. It says PowerShell script is not executing invoke web request, despite appearances. Instead, it's using an obfuscation technique involving PowerShell's variable naming syntax. So in this case, you can see that this whole thing is actually a variable name, and this is the value. And most of the time these days, LLMs trained specifically against these malicious scripts are able to figure this out pretty easily. Now, with that being said, it is still an LLM. It is going to make faults. It is going to hallucinate things. So always double check what it says. Now, with that being said, if I ask it, can you clean up the following variable names, and then assigning a variable named script, my script, to all of these values concatenated. Oops, I forgot to type in the script. There you go. And not quite what I was hoping for, but it did clean it up. And a lot of times, I actually found Claude to be very good at cleaning up obfuscated scripts. For example, let me bring up another script. Okay. For example, take a look at the following PowerShell scripts. Pick out only the parts that matter for execution and discard the noises. Let's see how it does. Oh, it's actually pretty big because of the payload. I'm gonna remove the payload part real quick because that's too big. And we're not interested in the actual payload anyways. Give me a second. So ideally, it should only spit out the part where it loads the payload. Yep, there it is. So it was able to actually go from all these noises that do nothing, but only leave in the important part. So, which is this part, which does the decode and loads the assembly down somewhere. So, yep. Here you go. I was just about to ask if you can use its token limitation to force it to hallucinate with big files. You probably could. The thing is, with Perplexity specifically, it does limit you to how big the file can be. Like, it is limited by the token size, and before it even gets to the token limit, Perplexity will actually prevent you from uploading whatever the large file is. But that is also one way of getting around it, yes. Also, keep in mind, your script could also contain prompt injection. I believe the code inside had been prompt injected before. I don't have the exact example, but someone did convince code inside to spit out, like, hey, this script is not malicious, when it actually is. So once again, be very careful with what you feed it. But like, before you even feed it into Claude, I would recommend actually cleaning it up first. So I would not suggest you put in like completely obfuscated scripts and then just feeding it directly into LLMs, because a lot of times, even if the LLM is good enough at deobfuscating, sometimes it will hallucinate values that aren't quite correct, and or it'll screw up somewhere. It is ideal that you give it the cleanest possible script and then tell it to, like, for example, like, you have almost all of the script ready. You got the part where it loads the payload, you've got the part where it defines all the functions, strings, etc., etc. The only thing left is for you to rename the variables so that they're easier for you to read. That is something Claude is very good at. It will actually go through the script and then rename all the variables for you. And that part it can't really screw up because it's just renaming things. That is the most ideal scenario where you would use LLM in. Okay, let's get back to the samples. Gonna hide this. I see, thanks. You're welcome. Sorry if I interrupted the pace of the stream. No. I am more than welcome to questions you might have. Okay, let's see what other ones there are. Okay, so this is more in line with what I expect Claude to do well in. A lot of times you'll see like very long variable names that you don't immediately know what they do, and or mixed casing in PowerShell scripts, where it's like, okay, I know from a glance this is system.txt encoding, but if it's anything longer or if it's anything more annoying to look at, you might not immediately figure out what thing it's doing, it's trying to reference and or call. That's the thing to follow. Now, let's turn off word wrapping. Sorry, turn on. As you can see, it's actually calling this it's trying to decode this very long base, presumably base 32 string here. We can once again use this as a demonstration as for how Claude might handle this. Give me a second. Okay. So if we copy this and then paste it in here and tell it rename the variables to something more sensical. How do I spell sensical again? Is sensical even a word? More readable. And discard comments. There you go. It's actually a lot more readable now. Look at that. So now we can paste it back into the thing we're looking at. So it's actually really good at things like this, where a lot of times it'll like not be something immediately readable, and then dumb it down into something we can actually read. And here we can see that this is actually the encoded payload. So we just rename this variable to that. And there you go. And if it's truly base 32, we can just feed all of that string into like CyberChef without actually doing this part. But it is a string inside, so it is more likely that there is another script here. So what we can do is base 64, sorry, base 32. And not quite. That's okay. Once again, what we can do is we get rid of the IEX. Just get rid of this part. And they'll spit it back out into the output. So that's 2E. Well, that did nothing. Just double checking that we didn't screw up the functions, so we can go back. Now that we know there's possibly an IEX anyways, we can just get rid of this part. Oops. There we go. Some of my screwed up some parts of the script there, but as you can see, now it's working. The main reason, sometimes when you feed the obfuscated script to Claude, to LLMs in general, is that sometimes they'll also reveal things that might not immediately stand out to you. So you can also just use what it says as a base reference for you to figure out, oh, okay, there is something that I missed. Because a lot of times when you're analyzing things, you might not notice everything that might be present. No, it doesn't look like it was doing anything not base 32 related. Because that does look like base 32. Oh, wait, I see the reason. Wait. So it's not quite using the same alphabet, I believe. Well, it's close enough. Well, regardless. Once again, back to the good old, if there's an IEX, get rid of it. And you'll be able to see whatever's going on. Oh, thank you for follow. Pepper Beagle. Okay, before we go on, I need a restroom break again. I'll be right back. I woke up my cat, who's now on the bed looking at me.
New subscriber!
Thank you for the resub link. Hello. Okay. By the way, you might have noticed the font size change. Don't worry about it. Right. I think we've been through all the samples here already, right? Let's see. Might have missed a few, actually. Nothing interesting there. Okay. I think we're done with the samples. Now, let me just also mention a few techniques that aren't always used, or rather not used as often. For some reason, I actually don't see them used very often. So, if your target is Windows, you already have quite a few variables available to you, as you can see in GV. And with these, you can actually, like earlier we did see something that used debug preference or verbose preference, and then taking the values from here. You can use a similar concept, but against some of the more, I would say, common variables. They're always going to be present on a Windows machine, and or always going to have the same value, if not very, very similar. Like, for example, if we take, I don't know, let's say a user profile. Oh yeah, by the way, if you want to use globally available environment variables, you prefix it with $env:. So we can do, like, for example, user profile. And we want, since we know user profile on a standard Windows machine is always going to be something that starts with C:/users/ and then followed by the username. You can use this as part of your obfuscated script as well if you want to. Like, for example, I can take the first character. Actually, first character might be a little bit risky, but because it might not be on C, it's almost always going to be on C, but not always. So I would probably skip the first character. Let's say, for example, I want to say take the S. Actually, let's take the E. E is more useful. So let's say if we want to spell out IEX. We can also take the I from somewhere else. Again, from GV, you can take a look at whatever might have I. Now, another way you can do this is you can also just reuse the same variable again. So you can cast it as a char, and then cast it as an int. How far away is I? I don't know. Let's see. Close? H, A, B, C, D, F, G, H, I. So, okay, that should go... Yeah, there we go, 4. So, we just do like... how far is X? Say like 20. 21? No, 19. Here you go. That's how you spell IEX. And then you just follow that with... Yeah, something like that. So, you can take advantage of the environment variables that you might almost always have. One other thing I like to use is something like, for example, Winter. Winter is almost always going to give you C:/Windows. You can take characters from there as well. Let's see, what are some other things I like to use for obfuscated PowerShell scripts? There's one very neat thing I learned about PowerShell not too long ago, is that you can actually use... Earlier we mentioned using pinvoke. So when you use p-invoke, you can actually give it way longer of a parameter, way longer of an argument count than what the p-invoke actually looks for. For example, if we bring back the memory patcher again, we know there was a virtual protect, right? Let's just do get module handle, right? Oop. Great, I broke it. There we go. Memory patcher. Get module handle. TDLO. You can actually, first of all, it doesn't have to be named get module handle. You can name it anything else as long as you override the name in here. And once again, since we're in a string, that also means we can substitute it with whatever variables that we have outside inside the PowerShell session. So let's, and also we can also rename the class name to something less sensical. So we can name it like, I don't know, ASDF, virtual protect, name it as like ZXCV, and then you can just call like ASDF, call ASDF, ZXCV, something like that. And what I was trying to say earlier is that you can give it longer of an argument than what actually matters, if you do it right. What was the one I was thinking of? Hang on. Let's bring up a good example here. I wonder why this doesn't work. It should. Right, because we're right. No. I know why. Because this is a it is an external call that's specifically. No, that doesn't make any sense. Okay, so the one I was thinking of was this script written by 60 Rivet Tails earlier. So the reason why this works is because, as you can see, sometimes it's calling. The first one is find Windows X, and then as you can see, it's actually reusing the same extern call. And so for find Windows X A, end task, and NT-raise harder, they're all using the same piece of extern. And the reason this works is because on x64, because most PowerShell sessions these days are running as a 64-bit .NET session. The reason this works is because in the x64 ABI convention, the caller does the cleanup. So you can get away with having a longer definition. Oh, right. That's why it earlier didn't work, because it was actually defining something. It was specifically defining a one argument as opposed to like a very long argument. So like in this case, you can actually define it as like a very, very long function. It'll still work. Like for example, if I just do like this, let's just say like what was it? It was kernel 32, right? Right, kernel 32. Yeah. Need to escape this still because we're in a double quote. As long as the type is correct, then you can get away with it. Oops. Right, and you give it a name. What? Did I miss something? Wait. There we go. That's why. There we go. Now we can call module handle. And then you can just give it like a bunch of unrelated arguments. And as long as the arc count fits, how many arcs was that? 1, 2, 3, 4, 5, 6. Yeah. It doesn't matter. Like, even though get module handle normally only takes one argument, if you give it multiple, if you define it and give it multiple arguments, and when you actually use it, you give it multiple arguments, it's not gonna matter because get module handle only takes one, and the rest is cleaned up by the ABI. So in theory, you can actually use this to write an extern call that would mislead people into thinking what it is actually. For example, I can replace this get module handle part and let's say do like virtual protect or something, and then give it like a really long name, and then put this in a variable and try to trick people into thinking it's a completely unrelated call, because you can also overwrite the actual API being called in the attribute as well. What else is there? I did mention type accelerator earlier. I don't use type accelerator often enough, but I think type accelerator is actually really good at disguising types. Also, since you are using .NET in theory, you're technically using .NET, there's a lot more things you can do since you have the entirety of the .NET base class library available to you. So don't be afraid to experiment with other .NET APIs as well if you are writing obfuscated scripts. What did I write here? Oh, right. Sorry, I was just looking through the random shenanigans that I wrote before. This is also another good point that I think would be interesting to bring up, is that not only do you have access to a bunch of environment variables that are typically available on a Windows session, but you can also make use of things that are going to be present on almost all of the Windows computer. Like, for example, let's just say we can take the command.exe and then take the string from there. So I can just do like GIC win, and you can use wildcard as well. Okay, that's too many of them. Let's do like D. Narrow it down. Equals 3. No, base name. There we go. So you can also use these really funky commandlets and try to get values that are almost always going to be on a Windows system. And then we can just, like, for example, take the name, and then we can do like /c calc.exe or something like that. We need to do this. And then we can just IEX. There we go. Now, for the thing that I pasted earlier, like for example, we can also use something like get process to get things that are almost always certainly going to be there on the Windows system. For example, it's probably going to be running Explorer. And let's just take the first one. And then we can do like select XP modules. Well, we can also see what it has. So let's go GM. Yep, there is modules. Also just do modules like that. And then there are almost always certainly going to be a certain DLL that's always going to be available, like Terminal 32, NTDLL, etc. So we can just take like name. Is it a name? Module name. There you go. And then we can do select, expand, module name. And then let's just say if we want to take like the last 4 characters, right? Unfortunately, you can just do something like this, like Python, but you can do substring. That's one way to do it. Substring. Does -4 work? No, it doesn't. Yeah, it can't be less than 0. The easiest thing would be just capturing this entire thing into a variable and then putting the name length here, and then, yeah, you get the idea. So with that, you can write something really screwed up. So let's take it, for example, if we want to obfuscate a simple write host hello world. Knowing what we've learned earlier, we can do get command. And then do, of course, we can obfuscate the string as well, but I'm not going to. Of course, that won't work because the GM is currently a cmdlet followed by that, so we might need to do n. It's not valid because we need the full name, right? I'm never sure. You can just paste it back into your PowerShell. Right. It's G. What was it again? If you're not sure what an alias resolves to, you can do the alias definition get command. There you go. So it's GCM. I'm stupid. Of course, you need the name. There you go. So now, we've got something like this. Of course, if you want, you could also obfuscate the GCM. So, I don't know if we learned this thus far. Yes. Explorer. Hell, you can even do PowerShell, because you're running in a PowerShell session right now. This thing also supports wildcard, so you can do this. We want... see what G is available. What member is available here. Hell, you don't even have to use the members in these. You can even sometimes take the name. For example, if I want to do... starts with... there should be a start with, right? Well, you can actually use regex as well for match. So, what was it? G? Is there even one that starts with G? No, there isn't. Select first. Got modules. Select first one. Select EXP module name. And we just use that. Take the first one. There you go. We now have a G. So this is pretty much what you do. If you want to, I would actually suggest you, if you're watching this, fire up a PowerShell session. Just do whatever. Like, have fun. Play around with it a little bit. I personally think writing obfuscated PowerShell by hand is really fun. Now obviously, if you're doing this at scale, this won't be feasible. But if you're just doing like red teaming, like for a one-off thing, then I would actually suggest firing up a PowerShell session. Just start banging out your own obfuscation, because not only is it a lot more fun, it's also sometimes less detectable as well, because you know a lot of the obfuscated scripts you can write your hard rules for. But if you're writing like something really stupid like one-off, you're never going to use this again. Then it also reduces the chance of being detected. Now, of course, with that being said, there's one very important thing that I haven't mentioned. Is PowerShell actually, whenever you execute something, it is monitored by ETW. So all the PowerShell commands you enter is actually gonna get logged, or not necessarily logged, but it'll at least trigger ETW. But if you have transcription enabled, then it will definitely log it somewhere. Just know that EDRs and various things will be monitoring your PowerShell sessions. Now, how do we go about, if you are an IT admin, how do you go about monitoring things like this? You can go into, if you are on your local computer, or if you're using policy across your AD, then what you can do is you can go into administrator templates, Windows components, and then finding PowerShell, where that is. Should be under Windows PowerShell. Here you go. So you can actually turn on module logging, you can turn on PowerShell script block logging, and turn on PowerShell transcription, which then you can define where you want the transcription to go to. So in this case, I actually already have it enabled, because sometimes when I'm looking at malware, I don't want to have to go through, manually doing this again and again. You can actually see that some of the stuff we executed earlier are here. So go in here. You can see each of the PowerShell transcription will tell you the environment of where it's running and what the current shell session has entered. So as you can see, all the commands I've entered and all the outputs that it spat out will be returned here. Now, that being said, there are ways of escaping transcription and or ETW in general. A lot of times what they'll do is sometimes they'll spawn in a new PowerShell session via a .NET instance. You can actually start a PowerShell session from within .NET, or from within C#. That's one way of going about bypassing it, because you're technically not in a PowerShell managed session. You are in a .NET environment of a PowerShell workspace. That doesn't get locked by default, I believe. Avatar, thank you. I'm just a student, so don't take my word too seriously. But PowerShell allows parallel code execution into another console. Using envvar obfuscation could potentially call EX, right? I'm not entirely sure if I'm reading this, understand this correctly. You mean like... and then into another PowerShell session, or... You can't technically, so in PowerShell you can't really do a persistent envvar, because as in like once you close the session, the envvar is gone because it's stored under user space. And technically you can use certain .NET calls and then store it into a system variable, sorry, a system envvar. But that requires elevation. And you'll probably get caught anyways, because this system envvar will be visible to all instances spawned from now on. We're having an example, actually. Yeah, you can use the environment. That's what I thought. Yep, you can use the environment class, which is responsible for many things. That's the GM from here. No. Get methods. Ah, there we go. Select name. Yeah, you can set environment variable from here. You can call set environment variable. Now, if you try to do this, obviously it wouldn't work because you need elevation. because system environment variables require elevation to change. So you can't really carry it into another session either. But in theory that you did, then yeah, you can carry that into another PowerShell session. But there's usually little point to it, because in that case, you might as well just like create another PowerShell session with the arguments passed into it. And also, like I said, your system environment variables are going to be seen by other processes. So for example, if let me restart system form real quick. So for example, if I open up PowerShell, yeah, all the environment variables are going to be visible here. And there are programmatic ways of retrieving these values as well. So you're going to be very easily seen if you're passing global variables around. What else is there? Let me check. Or some other shenanigans I've written before. Oh, this is a fun one. This is technically not PowerShell related, or at least not necessarily. Oh, but I don't have internet access to demonstrate here. Shoot. Well, I can talk about it anyways, I guess. So there are, since you have access to, PowerShell has a lot of default built-in commandlets that can do a lot of things. Like for example, invoke web request would just basically send a get request to wherever you want, and you can of course use that to retrieve additional strings from the internet. This will be default alias to IWR. So if you see an IWR, that's what it's doing. You can also do invoke REST method, right? Invoke REST method by default spits out a more structured response. Like invoke web request, I think it by default spits everything back out as plain string. But invoke REST method spits out like everything into their own properties, like response code, etc., etc. And in addition, you can also specify the method. I forgot if invoke web request also does method. Let me check. No, it does. Okay, yeah, it does. RM. So, in one way, IWR is actually superseded by IRM. The only reason I believe that it still exists is because IWR is there for legacy purposes, because it's been around since PowerShell 2, I believe. RM is only available on PowerShell 5 and above, I think. Don't quote me on that. You have to check the documents. You have to check the official documentation. But RM can also be very fun to use, because now we have things like DNS over HTTPS, right? So you can actually get away with some amount of DNS tunneling, or yeah, you can kind of disguise your traffic a little bit with DNS over HTTPS. So for example, what I have here is it uses Cloudflare to get the DNS record, specifically a TXT record from my domain. And then by default, the TXT records will be wrapped in quotes. So what I did here is also just remove the quotes and then just execute it. And this right now resolves to Mimikatz, I believe. Let me see if I can get the network working, actually. Give me a second. It's taking a little while because it's slow. There we go. Here, change the network adapter. Oh, my network card dies a lot. Now it's working. Yeah, now it's working. So if we take this should still work. I don't believe I changed it. Yeah, there you go. So it grabs the second stage from the TXT record. And normally, if you try to run this on your system, well, hang on. Oh, I thought it was working before. What is B-null? Oh, because it's escaped. Well, good to know that won't work. That should be replaced with backtick instead. That's why it doesn't work. Well, we get the idea. Let's see. What else is there? So earlier, actually we can check this right now. If we check this on VirusTotal. Thank you, by the way. No problem. So if we check this hash on VT, I actually uploaded at some point. Oh, there's no code inside, really. Can't reanalyze it. I don't think it's going to get any detection because it's doing something relatively benign. The reason why I want to check here is because, first of all, I'm not sure if Code Insight is available to non-logged in users. If it's not, then I won't be able to show you the Code Insight in action. But otherwise, Code Insight used to spit out what the PowerShell script does, and if I remember correctly, it did that horribly. I don't know if it's improved, but back in the days, if you checked Code Insight, it will actually give you things that often don't make any sense as it tries to read the obfuscated scripts. Yeah, it looks like it still doesn't do that, unfortunately. Normally what happens is it'll give you a block here that says, hey, this PowerShell script does what? Anything else I can check? So sometimes you'll also see obfuscated scripts like these. Once again, you might look at this and go like, okay, I can fix this, right? You can, but I wouldn't recommend it. A lot of times when you see format strings like this, like, yeah, you can technically piece it back together, but I would honestly just recommend letting PowerShell evaluate it instead. In this case, it's trying to set the variable name. It's actually just a TCP client. SV is set variable. So it's creating a new variable called PW4C and then whatever this is. Also, when you're writing scripts, when you're writing obfuscated scripts, be sure to also check out what aliases there are. You can also set your own aliases as well. So I can do like, and just do right host, and then here you go. That's also another way of obfuscating things. You can just have completely incomprehensible names and then let it represent some other commandlet that you might use. So in today's session, I've taught you how to give a pretty quick overview of the obfuscating PowerShell scripts. You've learned how PowerShell works. That's case insensitive. You can redirect types into another named types using type accelerator. You can alias various commandlets into other commandlets or into other really annoying to look at strings. And then using values that are almost always present on the Windows machine, using that as part of your obfuscated variables, and etc. etc. If you like to experiment at home, I would highly encourage you to check out some of the samples on abuse.ch. That way you can get a good understanding of what threat actors are doing these days to obfuscate their scripts. Alternatively, you can also fire up your own PowerShell session and see what stupid scripts you can write. If you, it's a fun hobby, I would say, if you're bored. Just to see what screwed up, what fucked up scripts you can write. And or alternatively, like I said, check out the samples. You can figure out what people are doing these days, what people are doing with their scripts. You can actually a lot of times learn new obfuscation techniques just by looking at what others are doing with theirs. Like for example, like what I mentioned earlier with execution context. You can do a lot of things here. This execution context method I actually learned from Luma Stealer, which in turn was actually using the script from Invoke Crafter. Initially, I thought that was something this Luma Stealer team came up with, but no, turns out it's just from Invoke Obfuscator. I'll also occasionally write write-ups from these PowerShell scripts. If I learn anything new, I'll put them up on my Twitter as well. I think that's all. Somehow I managed to talk for 3 hours. I honestly expected it to be like more like 2 hours. So, let's see who we can raid for the people on Twitch. It's almost 2 a.m. I'm pretty tired. I still gotta pack as well because I'm going back home for the weekend. Don't know if I could ask, but any recommendation on where to get samples? So, like I mentioned earlier, there is abuse.ch. You can go check out my bazaar. I will link now in the chat. And then you can do like file type PS1. Right? File type, let me check. Is it file type? Yes, file type. So PS1 is the extension for PowerShell scripts. Okay. Right. Back to what I was, back to what I was saying. Let's see what can raid. No one. Similar or smaller size. Let's see. Is Kirby Air Riders available to play already? Why are there so many people streaming? Let me check Twitch front page actually. Oh yeah, do you guys hear Hololive is streaming on Twitch now? When I checked the front page, like I'm immediately greeted by like 4 Hololive streams. Let's see. Oh, so is Kirby Air Rider actually out now? Because I've seen a lot of people play it already. I know the review dropped. Okay, it's out. Okay. Yeah, screw it. I'll send you guys over to Rafi. The mods for Neuro's chat. Rafi. Have a night. Thank you. Send you guys over. I still got a pack as well. God. I am tired. Okay, we will see you guys sometime next week. Bye-bye.